On this video, I'm going to go over number 9 on your 2.1, 2.2 homework. And they have a question help button on this one, and you can see an example. The calculus part of this is pretty straightforward. It's really the algebra that gets ugly, and it's because these numbers are so annoying to deal with. However, you're going to use the quadratic formula. You can use the quadratic formula to know that t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So once you find the derivative of this function and set it equal to 0, you can solve it by using this formula and plugging it into your calculator. So taking the derivative of a of t is pretty straightforward, right? I take the power 3 down and I multiply 3 by the coefficient. And that gives me 0.0795 t squared minus the derivative of the second term here, which would be 2 times the coefficients, would be 0.912 t, plus here the power of t is 1, so it would just be the coefficient, and then that would be t to the 0 power, so we don't write that. And then the derivative of a constant is 0. So this is my quadratic that I'm trying to find any critical points. And I can find critical points by taking the quadratic and setting that equal to 0 and solving when that happens. So plugging in the quadratic formula, this would be my a term here. This would be my b term. This would be my c term. So using my calculator, I can just plug that in, and I end up with t equaling 2.491924 and t equaling 8.8780705. This is a little annoying because these numbers are just annoying to deal with, but we still utilize them the same way. So if I'm looking at the first derivative and I'm just looking at 2.49 and I'm looking at 8.97, right? Our interval only goes between 0 and 10. So I want to look at the sign of this function. If I plug in a number less than 2, so if I plug in 1 or if I plug in I want to know the sign of the derivative. And if I plug that in, I get the sign of the derivative is positive. And I can see if I plug in t equals 0, then I get 1.779, which means that's positive. If I plug in a number between 2.49 and 8.97, it turns out the number is going to be negative. And then on the other side of 8.97, it's positive. So my graph of my function is increasing on this interval, decreasing on this interval, and increasing on this interval. So it should look something like this in the graph section. This would be a maximum, and this is going to be a minimum. And the problem wants us to input our answer rounded 4 decimal places, but as a ordered pair. So I need to plug this value into a of t, into the original expression, and see what I get out. And when I plug in 2.49, you have to be a little careful here. Nope, I wrote that wrong, sorry. 2.49, oh wait, yeah, 19. So if I plug this number, I end up with 10.8716, and I need to round this to 4 decimals, like our instructions say. We want to round 4 decimals as needed. So rounding 4 decimals, this is a 9, it's going to bump this 9 up, which is going to bump that up to this. So it can be a little tedious to plug in because when you plug it into the expression, you don't want to round to get this answer. Turns out if you do round it before you plug it in, since you're rounding 4 decimals, it doesn't change it. So this is going to be the maximum point. This is a maximum. So you want to make sure that you plug this point in for the maximum. The minimum is going to appear when I plug in the 8.9797. And when I plug that in, I get 7.2534. 2534. This is the minimum point. Right? So depending on what it's asking, you want to make sure that you're plugging in the maximum and the minimum. And then the graph of the function in my math lab, it's a little tedious. Pull that over there, your options. So graphing it, you just want to see something that's going to look like this. I'm going to have a maximum around 2.5 and I'm going to have a minimum around close to 9. So my function should go up, down, and then up again. So this one goes up and then down, then up again. This one doesn't, and this one doesn't. This one does the opposite. This is a minimum here and a maximum here. So the only option here would be this one. And if you zoom in, you'll see that around 2.5, this is where the maximum occurs, and around 9 is where the minimum occurs. So hopefully that explains kind of what's going on here. The calculus itself would be to take the derivative. Everything else is kind of algebra and plugging it in your calculator and being very careful by hitting the right sequence of buttons. So please let me know if you have any other questions.